All right, so today we're going to start 4.2, and it deals with classifying triangles. So a triangle is a figure formed by three sides. The point where segments meet is called the vertex, and the segments are the sides of the triangles. So we have triangle here, ABC. The vertices are A, B, and C. And the sides are segment AB, segment BC, and segment AC. And the angles are angle A, angle B, and angle C. We can classify triangles two ways. One way is by the angles. So a triangle where all angles are less than 90 degrees is called an acute triangle. A triangle that has one angle that's greater than 90 degrees is an obtuse triangle. A triangle that has one angle that's equal to 90 degrees is a right triangle. And a triangle that all the angles are equal is an equiangular triangle. So on this page it has 4 examples of each of those triangles. I have an example. Classify the triangle by its angle measures. So in this one, let's look at triangle BCD. So we're looking at triangle BCD. What type of triangle do we think this one would be? Obtuse. Why do you think it's obtuse? So what makes an angle obtuse?
It's above 90 degrees.
If one of the angles is above 90 degrees. So here we have an angle that's 100. So since angle B is greater than 90, it is obtuse. Yes. Yes. So classify triangle FHG by its angle measure. So now we're looking at FHG.
It's acute.
Why is it acute?
Because it has an angle.
How do we know what the top angle is?
It's obtuse. Oh wait, never mind.
So if we see that EHG is 90 and EHF is 30, so we have angle FHG, so this one here, plus 30 is equal to 90.
So it's a right triangle.
Well, we're saying that these two angles, so this blue one is 30 and this green one is FHG, and they're equal to 90 because we see this box here. So to find angle FHG, we subtract 30 from both sides, so we get angle FHG is equal to 60. So now we know this top angle is also 60. So if we have three angles of the triangle that are the same, 60 degrees, what type of triangle is this? Equiangular. The second way we can classify triangles is by the sides. So a triangle that has no sides the same length is a scalene triangle. A triangle that has at least two sides the same is called an isosceles triangle. And a triangle that has all sides that are equal is an equilateral triangle. So classify triangle EHF by its side lengths. So we're looking at EHF. What type of triangle do we think this is? Isosceles. Because we have these tick marks that show that side EF and side FH are the same. So both of these would be 10. So we have two sides of the triangle that are equal, so this would be an isosceles triangle. Classify triangle EHG by its side lengths. So now we're looking at EHG. So we have a side that's 12, a side that's 11, and a side that's 14. What type of triangle? Scalene. So this is a scalene triangle because no three sides are the same. So classify triangle ACD. So we're looking at this triangle to the right, ACD. What type of triangle do we think this one is?
Isosceles.
Daniel Fernandez, District 1?
Yes.
Yes.
So this side here is 15.
Sorry, Shirley.
So we have a side that's 5, a side that's 15, and a side that's 18. So no three sides are the same, so this is a scalene triangle. So find the side lengths of triangle JKL. How would we find the sides? Joseph.
I don't know, I was just thinking, can't you just like make it as an equation? I don't know.
So what would our equation look like?
4x minus 10.7 is equal to 5x plus 2.
Well, we don't know, so you're saying that this one's equal to this one. We don't know that those two are equal. But what's another side? What's two sides that we know are equal?
You would do 4x minus 10.7 equals 2x plus 6.3.
Right, so we have to use the two sides that have the tick marks. So we know that JK is equal to KL. So we would do 4x minus 10.7 is equal to 2x plus 6.3. So we have to use the side with the tick marks and set those two equal. And now we solve for x. So we can add 10.7 to both sides and subtract 2x. So we get 2x is equal to 17. And we can divide by 2. We get x is equal to what?
8.5.
8.5. So now that we found x, we can take this and plug it in to all three sides. So for side JK, we get 4 times 8.5 minus 10.7 is equal to what's 4 times 8.5?
63.
4 times 8.5?
34.
34.
Oh, yeah.
Minus 10.7?
24.7.
23.7. 23.3. So we found JK. We know that KL is equal to JK, so we know that KL is going to be 23.3 also. And now to find JL, we can plug 8.5 into x again. So we do 5 times 8.5 plus 2 is equal to 44.5.
42.
Yeah, 44.5.
Did you add the 2? So 44.5. So we found the 3 side lengths here. And yes, it's an isosceles triangle because we have the 2 tick marks, which show that 2 of the sides are congruent. Last example, find the side lengths of the equilateral triangle FGH. So if this is an equilateral triangle, what do we know about all the sides?
They're the same.
They're the same. So we can pick 2 and set them equal to each other. So what 2 do you want to use?
3y minus 4 equals 2y plus 3.
So 3y minus 4 is equal to 2y plus 3. So we just solve for y. Subtract 2y from both sides, and we can add 4 to both sides. So we get y is equal to 7. So now we take this, and we plug it into all the sides.
Just do one thing wrong.
Yeah. So let's plug it into side FG. So we have 3 times 7 minus 4, which is equal to 17. We don't even need to plug it into the other 2 because we know that all 3 sides are going to be equal. So what would side GH be? 17. And what would side FH be? 17. So that's 4.2.